Okay, we're going to learn today, good evening today, and we're going to continue to learn the thermometer question, and we're going to learn specific heat capacity today. Okay, and the question I gave last week, I gave question. The question is okay, these questions. Okay, this question, this one is -5 and this one is 0 and this one is 100 and the length, total length is 25 cm. Total length is 25 cm. Okay, the question, first question, if the length of the mercury column is 18 cm, find the temperature, what do you call it, temperature of what do you call the liquid. Okay, 18 cm. So 25 cm. 25 cm is equals to how many degrees Celsius? 100 minus 5. 100 minus 5. 100 minus minus 5 is 100 minus 5. So it's 105 degrees Celsius difference. So 105 degrees Celsius. 25 cm, the difference 105 degrees Celsius. So 1 cm is equals to 105 divided by 25. So equals to 1 cm equals to 4.2 degrees Celsius. 1 cm equals to 4.2 cm. 4.2 cm. 18 cm. 18 times 4.2. 18 times 4.2. 80 cm. For 18 cm, the temperature. So this equals to temperature 75.6 degrees Celsius. 75.6 degrees Celsius. Okay, but that is not the temperature. That is not the temperature. For 18 cm we measure from -5. -5. You measure from -5, 18 cm. Okay, 18 cm. This one is 18 cm. For 18 cm from -5, 18 cm, the temperature is 75.6. But our temperature is measured from 0. Our temperature is measured from 0. So 0 means you must minus. So 18 cm is measured from -5 to -5, 18 cm. So -5, 18 cm. Okay, this 18 cm lah. 18 cm temperature is 75.6. But actually our temperature is measured from 0. So the actual temperature equals to 70.6 minus 5 because you are taking a temperature 0 from 0 temperature. So the temperature is 75.6 minus 5 is 70.6 degrees Celsius. This is actual one. 70.6 degrees Celsius. For 18 cm length, the temperature is 70.6 degrees Celsius. It's not 75.6 degrees Celsius. 75.6 degrees Celsius, we include -5. But our temperature is measured from 0. Temperature is measured from 0. 0. So our benchmark or our scale start from 0. So it's we call 70.6 degrees Celsius. Okay. Now, what is the temperature? 60 degrees Celsius. 60 degrees Celsius. So this question B, question number 2 or B, I think I should B. If a temperature 60 degrees Celsius, what is the length? We call it length of the mercury column. 60 degrees Celsius. For 60 degrees Celsius, okay, 25 cm. 25 cm is 105 degrees Celsius. Okay, we can minus 5 lah. Okay, 20 cm for 20 cm. Okay, 25 cm. for 25 cm, the temperature is 105 degrees Celsius. 1 cm is 4.2 degrees Celsius. 1 cm is 4.2 degrees Celsius. 4.2 degrees Celsius for 60 degrees. 60 degrees. So I don't have calculator now. Okay, but I will tell you how to do it. You have to practice it. So say for 60, for marker 60 degrees Celsius. So it's 60 divided by 4.2. 60 divided by 4.2, 1 cm. So equals to how many cm? Okay, how many cm? Equal to cm. The cm. Then that one is from 0. You plus from 0 to 60 degrees Celsius. 0 to 60 degrees Celsius. This cm, this xcm, xcm. 60 divided by 4.2 xcm. You get xcm, x. But this one you must plus cm. 0 to 5. 0 to 5. You must plus. So the total length of the mercury column you must take from negative 5. So you must 60 degrees Celsius, 0 to 60 degrees Celsius. So 60 divided by 4.2. So how many cm? Xcm. So this is xcm. So xcm must plus this cm. You have to find for 5 degrees Celsius what is length of what do you call it for length of 5 degrees Celsius. So you must find plus. Okay, for example, 5 degrees Celsius so length for 5 degrees Celsius. So 4.2. So 4.2. 5 degrees Celsius divided by 4.2, you get the ycm. So this one is for we call it 5 degrees Celsius, 4.2. So it's how many cm now? Ycm. So ycm. So the total mercury column x plus y. X here and plus y. X is here 60 divided by 4.2 xcm and plus y. Ycm is 5 degrees Celsius divided by 4.2. So it's ycm. So y plus x plus y. So that is called total length of mercury column for 60 degrees Celsius. Okay, total length of mercury column is measured from negative 5 because length of mercury column is not starting from 0. Temperature starting from 0. Okay, but length of mercury column starting from negative 5. So negative 5 you must measure this one plus y plus x. Okay. We are going to learn today specific heat capacity. Okay, I will give questions to you today with this lesson. I will give questions to you today. Okay, specific heat capacity. What is specific heat capacity? Okay, quantity of heat required. Okay, this one is a specific heat capacity or small symbol c, small c. Specific heat capacity. Specific heat capacity means quantity of heat required or needed to increase the temperature, quantity of heat required to increase the temperature of 1 kilogram substance, 1 kilogram substance by 1 degree Celsius or by 1 Kelvin. See, quantity of heat required or needed to increase the temperature of 1 kilogram substance by 1 degree Celsius, or we call it as 1 Kelvin. 1 Kelvin. For example, for example, I give you this one. This is a definition. Okay, I'll give you this one. Okay, specific heat capacity. Okay, for example, the unit is joule per kilogram per degree Celsius. Unit specific heat capacity unit is joule per kilogram per degree Celsius. Joule per kilogram per degree Celsius. Okay, and for example, what is the meaning of specific heat capacity? For example, okay, let's say the temperature. Let's say object A, the mass is 1 kg. Let's say the object mass is 1 kg, and the temperature is 20 degrees Celsius. Okay, you heat up. You give the heat. Okay, and you measure the heat. Heat is about 500 joule. You measure the heat, okay? Heat 500 joule to increase the temperature 21 degrees Celsius. Okay, from 20 to 21, how much increase temperature? 1 degree Celsius. 20 to 21, 1 degree Celsius increase. Okay, for 1 kilogram object, how much heat needed is 500 joule. So specific heat capacity object A. Specific heat capacity object A is 500 joule per kilogram per degree Celsius. What is the meaning? Okay, I will explain to you this again. 500 joule of heat energy. 500 joule of heat energy required to increase the temperature of 1 kilogram substance by 1 degree Celsius. 20, 21 or 25, 26 or 42, 43. This is 1 degree Celsius. Increase 1 degree Celsius by 1 kilogram. 1 kilogram substance. Okay, 1 kilogram substance, 1 degree Celsius. What is the increase? So that is called 500 joule. Okay, let's say object B. Object B is about 4000 joule per kilogram per degree Celsius. Object B is object A, object B. So the specific heat capacity is 4000 joule per kilogram per degree Celsius. How to define this? Sometimes the exam they ask, they give the number, they ask to define the energy. Okay, let's say they give specific heat capacity object B is 4000 joule per kilogram per degree Celsius. Okay, what is requirement? So you must write like this. You must say like this: 4000 joule of heat energy is required to increase the temperature of 1 kilogram substance B by 1 degree Celsius. I repeat again: 4000 joule of heat energy. 4000 joule of heat energy is required to increase the temperature of 1 kilogram substance B by 1 degree Celsius. That is the meaning. Or we can say other way around. We can say other way around. To increase the temperature of 1 kilogram substance B by 1 degree Celsius, the required energy is 4000 joule. Okay, required joule is 4000 joule. Required joule energy, heat energy. Okay, it's easy way this way lah. 4000 joule of heat energy. 4000 joule of heat energy required to increase the temperature of 1 kilogram substance B by 1 degree Celsius. That is the meaning of specific heat capacity, 4000 joule of kilogram per joule per kilogram per degree Celsius. Okay. Okay. Now I'm going to do this formula. This is a formula. So a little bit formula. Okay. There's a formula. Okay. This formula Q equals to mc theta. Q equals to mc theta. Q equals to mc theta. Theta is one theta, is one Q. So what is the meaning of this one? Q means what? Q means quantity of heat energy measured in joule. Quantity of heat measured in joule. M equals to mass measured in kilogram. C means specific heat capacity. The unit is joule per kilogram per degree Celsius. Specific heat capacity, joule per kilogram per degree Celsius. Okay, specific heat capacity. The C, specific heat capacity of particular material, for copper, aluminium, or water. These are different specific heat capacity. And the theta is very important. Difference in temperature. Degree Celsius. The unit degree Celsius. So the Q is quantity of heat, joule, in joule. M is mass, the unit kilogram. C is specific heat capacity, unit joule per kilogram per degree Celsius. And theta means difference in temperature, degree Celsius. Okay, difference in temperature. Okay, this one we use this formula. Even though specific heat capacity definition says to increase the temperature by 1 degree Celsius, but to decrease the temperature 1 degree Celsius or decrease the temperature also can use this formula. So the difference, the object A, for example, object A, the initial temperature 20 to 25. So the difference in temperature 5 degrees Celsius. Okay. The same object A, temperature can reduce 20 to 15. So the difference in temperature 5 or 20 to 14. Difference temperature is 6. So by the way, the theta cannot be negative. You must remember this one. You will see some questions, negative degree Celsius or something like this. You will see some questions will be a bit tougher and tougher. This topic is a bit tougher, right? But we can adjust this one, okay? But theta, you can see some temperature. They give -5 to -10. All this temperature is the increase in temperature. But theta cannot be negative value. Theta cannot be negative value. C negative value cannot be, and negative value cannot be. Okay, and also C also, theta also, all these three also it cannot be negative value. Theta especially cannot be negative value. Is like this: higher temperature minus lower temperature. Higher temperature minus lower temperature. Just remember this one. For example, in the case of increased temperature, is the final temperature higher and the initial temperature is lower. So final temperature minus initial temperature. In the case of decreased temperature, the initial temperature is higher and the final temperature is lower. Initial temperature is higher, final temperature lower. So initial temperature minus final temperature. So higher temperature minus lower temperature. So can you understand this one? Higher temperature minus lower temperature. That is for decreasing temperature. Increased temperature, higher temperature, the initial temperature lower, the final temperature higher. So the final temperature minus initial temperature. That is called for increased temperature. For decreased temperature, the initial temperature higher and the final temperature lower. So the one to find the difference in temperature or theta is a initial temperature minus final temperature. So I will do questions to you later. Later I will do questions for you. You can understand this one better. Okay, you can understand better. Okay, and this question is okay. Can you see? Okay, this one. For example, A is 2 kg. The temperature is from 20 to 25 degrees Celsius. How much heat energy required? How much heat energy required? Okay, the object A, the specific heat capacity A, the object A, I give specific heat capacity object A is 500 joule per kilogram per degree Celsius. So, joule per 500, okay. So, the formula Q equals to mc theta. The M is 2 kg. So, this one is more than 1 kg. Specific heat capacity is about 1 kg. But more than 1 kg, we have to use this formula. So, M equals to 2 kg. The M is 2 kg. The specific heat capacity object A is 500 and the theta equals to 5 degrees Celsius. Theta is difference in temperature from 20 to 25 degrees Celsius. So difference is 25 minus 20. Okay, I will write the right 25 minus 20. No? Final temperature minus initial temperature, or higher temperature minus lower temperature. Okay, this one is about 2 times 1000. 1000. This one times 5 is 5000 joule. 5000 joule of heat energy. Q is quantity of heat. So 5000 joule of heat energy required. Okay, 5000 joule of heat energy required. This is a very simple question. We are going to learn some tougher question later. Okay, and this one, specific capacity. We are going to learn something like a theory. We are going to learn specific capacity. Specific capacity. Okay, specific capacity, low specific capacity and high specific capacity. The difference, very important. Very important. I give a very simple notes but very deep meaning in it. So many application question. For example, what do you call it? The pan, or we call it heating pan. We call it a car carburetor. What do you call it? Radiator, car radiator, water, heater system. So all these things involving specific heat capacity. Please remember. And we call it land breeze and sea breeze. Okay, land breeze and sea breeze. Have you heard of geography? Land breeze, sea breeze. Specific heat capacity involved. In geography, we don't learn specific heat capacity. We don't mention about specific heat capacity. But in physics, you must mention specific heat capacity when you explain land breeze and sea breeze, how it occurs. So I will go through this one to you another couple of weeks. Okay, about another 2 weeks time. 2 weeks maybe. This next class, God willing. Next class we're going to learn we're going to learn maybe, okay, we're going to learn some of the application questions, okay. So now we are going to learn low specific heat capacity and high specific capacity. For example, the low specific capacity object A is 500, for example, 500 joule per kilogram per degree Celsius. High specific capacity object B is 4000 joule per kilogram per degree Celsius. Okay, the low specific heat capacity 500 joule per kilogram per degree Celsius. High specific capacity, for example, 4000 joule per kilogram per degree Celsius. Okay, substance A, substance B. Okay, one thing about the specific capacity, it differs from one substance to another substance. For example, specific capacity water is 4200 joule per kilogram per degree Celsius. Specific capacity aluminium, I think, is 900 joule per kilogram per degree Celsius. So, and specific capacity plumbum or lead is 130 kilogram per joule per kilogram per degree Celsius. So, this differs specific capacity. So, material type. Okay. Now, the first thing, the first point, temperature increases or decreases. Temperature decreases or increases quickly or fast. Okay, temperature, the object having low specific heat capacity, substance having low specific heat capacity, temperature increases or decreases quickly. But this one, temperature increases or decreases slowly. Okay, slowly. Second point, large increase or decrease in temperature. Okay, large increase or decrease in temperature. Okay, large increase, there's a decrease or increase, so much difference. Okay, low specific heat capacity substance having large increase or decrease in temperature. Large is a small increase or decrease in temperature. Okay, this is large increase or decrease in temperature, is small increase or decrease or temperature. The third point, good heat conductor. This is a good heat conductor. Good heat conductor. This one is poor heat conductor. Okay, this is a good heat conductor. Heat conductivity. So increased temperature very fast increase temperature. Heat conductor, conductivity, good heat conductor. Very fast can increase temperature. Very fast, the object can heat it up. But it's not slowly. The object heat it up slowly, or poor heat conductor. For example, okay. Metals. All the metals are good heat conductor. Metals. An example is water. Okay. Water. This is one. We call it. I repeat again. The substance having low specific heat capacity, the substance having high specific heat capacity. The substance having low specific heat capacity, the substance temperature decreases quickly. Temperature increases or decreases quickly, very fast. And the large decrease in temperature, the difference in temperature, so much difference. Initial temperature and the final temperature, or final temperature or initial temperature. So the difference in temperature, large increase. Okay, large increase or large decrease in temperature. That is called low specific capacity material or substance. Good heat conductors. They are good heat conductors. They can conduct heat quickly. They become heated up quickly. They can heat up quickly. Okay, good heat conductor. For example, metals. And high specific heat capacity, temperature decreases slowly, very slow increase or very slow decrease. Small increase or decrease in temperature, very small increase, For example, temperature, this one is a large increase, so it heat up, for example, 500 joule. You give the same 500 joule for low specific capacity, high specific capacity, 500 joule, you give heat. I will explain this one to you next week, next class, next lesson, we're reading more clearly. Okay, this one is 500 joule. Let's say object A and object B, you give 500 joule heat energy equal, but object A temperature increased from 20 to 28, but object B temperature increased 20 to 22. So it's more increase. But as a matter of fact, both receive same amount heat. Both object A and object B receive same amount heat, 500 joule for example. But object A temperature increased very fast, very high, 28 degrees, 20 to 28 for example. But temperature object B, the temperature increased for 20 to 22. But same time, they measured the same time. But same heat. Okay. And good heat conductor, for example, metals, and a poor heat conductor. This is a poor heat conductor, water. So it's not heat up quickly. Okay. Today I will finish this lesson today. Okay, this lesson today. And I will give question to you for you to do some questions. I will see you next class. Okay, thank you.